There are a number of benefits to an algorithmically decomposed program. One of the benefits, this divide and conquer approach, top-down, based on the actions performed by the system, is actually relatively intuitive to developers who've been trained to think about programming and problem solving in an algorithmic manner. And that's actually very common, especially people who learned to program back in the 80s and early 90s before object orientation became quite as popular as it is today. The algorithmic approach maps relatively cleanly and efficiently onto language features you'll find in second generation and third generation programming languages, things like structs and functions that you might find in C. So once again, there's a fairly intuitive match. If you read a lot of literature about how to do certain kinds of programming, you'll see this particular style used fairly commonly throughout the years. One of the other benefits of an algorithmic approach is that there's no necessary reason to use certain programming language features that are sometimes implemented with a certain amount of overhead. For example, in object-oriented languages, or a dynamically bound function is often implemented with a few extra levels of indirection, which means when you invoke your operations, they take just a little bit longer to run than if you were to implement them using a non-virtual function or an inline function. Of course, however, there are also some significant limitations with algorithmic decomposition. And it's important to have a fairly deep understanding of that because that helps to motivate the focus on objects and the focus on patterns. One of the problems with algorithmic decomposition is the complexity of the system tends to reside in the algorithms, which are often variable and tend to change, rather than in the structure, which tends to be more stable if you do it right. So for example, if we go back and take a look at our print tree function that we looked at before, you'll see a couple of interesting things. First of all, the data structure of the tree node is relatively passive. It exports all of its operations to the functions. Those functions can come along and look inside and play around with any of the fields that they so choose. There's no protection taking place here. And the functions are really what do all the work. The data structure just kind of sits there and lets the functions have their way with what they're doing. Another typical problem with designs that use this particular approach is that switching on type tags is notoriously tedious and error-prone, especially in languages like C, such as Java, C++, Objective-C, and so on, where there's lots of error-prone issues, accidental complexities, where you forget to put in a break statement or something else comes along and you forget to handle the cases properly. Moreover, whenever you have to make any changes to your design and implementation, you'll also have to end up adding explicitly more cases to your switch statement. And it's all too easy to forget how to do that properly. There's also some other limitations with the algorithmic approach due to an incomplete and inefficient modeling of the expression tree domain. For example, you'll notice if you look carefully at the tree node data structure, there's a very tight coupling between nodes and edges in the design. We combine them together so that they have the same shared piece of memory to store either the operator or the operand value. And that's just a tight coupling that occurs in the design space. One of the consequences of doing these things as well is that you end up wasting a lot of space, because even in the case where you have what should be the minimally sized node, the leaf node or the number operand, you still end up incurring the overhead for all the other fields that are unused because we've used a struct with a number of unions in there. And so in all cases, we'll take roughly the same amount of space, even though much of the time, in fact, half the time, we don't need to have the space for the children pointers in a leaf node. There's also a problem here with little or no encapsulation. The implementation details are completely exposed to clients. The client application, which in this case would be the print tree function and so on, is able to peek inside, grab that type tag, grab the various numbers, grab the ops, grab the left child, the right children, and so on, and do whatever they feel like with them. And if you make any changes whatsoever in the software, it's going to end up rippling through many parts of the code. Another consequence that you sometimes run into when you program it in languages like C, which make heavy use of macros, is pollution of the global namespace. So what happens here is if you define various macros that have fairly common names like unary or binary or whatnot, those things can actually conflict with other symbols that exist in other parts of the code having nothing whatsoever to do with your expression tree application, and yet you'll subtly and erroneously redefine what those symbols mean. That's a very hard problem to track down. Believe me, I know from experience. So by doing things this way, changes ripple through the entire program when you make any modifications. For example, if we were to come along and try to add some kind of ternary operator to our expression tree, we would find we'd have to add a new case to our switch statements. We'd have to add new enumerated literals to our enumerated type. We'd have to add additional space to be used to hold the operators, the number and operator field. We'd have to find another way to add an additional struct that would be used to keep track of 3 children instead of 2 that we had before. And there would be just changes all over the place. We'd have to change the functions and so on and so forth. So clearly this would become tedious and error prone, and you'd have to probably make these changes in many parts of the code. Any part of the code that actually switched on the type tag would have to be inspected, checked out from your source code control system, modified, retested, rerun, checked back in again, and so on. And this could become very tedious and error prone.